Hello, so let us look at the second part of the review, starting from number 11. So here we want to simplify complex fractions. How to approach it? Yes, you have to multiply each term by the common denominator. So when you look at the first one, a, what do you think the common denominator is? Okay, that's right. In fact, it is equal to 2a. So we're going to multiply each one by 2a to all the terms. Then you can see that a and a cancels out here. Here as well. In this case, 2 will cancel out. Then what's left? 2a from the first term plus 4, and then 4 minus a squared. Alright, so then after this one, we have to factor the numerator and denominator and see if we can simplify any further. We can see that 2 is the common factor. Then that's what we end up getting. Denominator is a difference of squares, so we have 2 plus a, and then 2 minus a. And then in this case, then do we have anything for us to cancel? Yes, we do. A plus 2 and 2 plus a. Since both of them are positive numbers, we can switch the order and then nothing would have changed. So therefore our final answer is 2 on top and 2 minus a is left at the bottom. So that's how we would have approached question A. How about B? What can I multiply? The common denominator for this one, in fact, it would have been equal to x. So if you multiply everything by x, as you can see over here, then first term becomes x squared, and second term becomes 9 because x and x cancels out, and it becomes x plus 3. Now, can we factor this one further? See, x squared minus 9 is the difference of two perfect squares, so we get x plus 3 and x minus 3. And then denominator was x plus 3 as it was written before. Then x plus 3 cancels out here. So therefore, what's our final answer? It was equal to x minus 3. Alright, that's basically how we can approach question A and B. Let's look at further questions. How about C? What is the common factor? Obviously, in terms of number-wise, it has to be 16 because 16 is bigger, and then 4 is a factor of 16. Now, in terms of x squared and x, of course, x squared is more inclusive, and then there will be the common multiple. So therefore, in this case, our common denominator would have been 16x squared. So that's what we're going to multiply to all 4 terms here. Alright, now let's see if you can cancel anything here. First one is simply 16x squared. But the second term, we get to see that 1. Why? Because the entire 16x squares cancels out. Third one is simply 16x squared. And fourth one is minus 4x. Why? Because 16 and 4 cancels out, get us 4. X squared and x cancels out, getting us x. Did you notice that this one is in fact also a perfect square? Because 16 is a perfect square, so is x squared. And also 1 as well. Then when you use the difference of squares to factor the numerator, we would have gotten 4x plus 1 and 4x minus 1. And then how about the denominator? You see 4x was common, so if you factor out GCF, then this is what I have. Then obviously the 4x minus 1 is common in top and bottom, so we can cancel them out. And there isn't anything else. Be careful, we cannot cancel out 4x's because the numerator has plus 1, while the denominator doesn't. So our final answer for this question C would have been this. 4x plus 1 over 4x. Alright, how about D? What can you multiply so that a complex fraction will be simplified a bit further? Yes, 2c was the value because that was a common denominator. Alright, then what happened here? C squared because 2 cancels out. And second term, c's cancels out, becomes minus 4. Notice that this is a difference of perfect squares. So we're going to use that a bit later. And 2c times 1 is 2c. And then second one, 2's cancels out. So plus we have c squared. Now, as I mentioned before, let's try to factor these things out. So here we have c plus 2 and c minus 2. Due to the difference of squares. Denominator, we have c's being common to each other. So we have c and then 2 plus c. Then do you see anything which you can cancel out? That's right. C plus 2's are cancelled out. So we have c minus 2 over c becomes our final answer. Alright, then let's move on to the next question. So when we want to simplify the radicals, what do? In case of number 12, it's recommended that you multiply or divide first before you simplify. So here, I'm going to rewrite number 12 as the 900 divided by 20. Now then, if you divide 900 by 20, you will see that it will be in fact equal to square root of 45. Now 45 is quite nice because 45 is made by 9, which is a perfect square, times 5. So square root of 9 times square root of 5. So our answer is 3 square root of 5. Not bad. How about number 13? But before we add or subtract, what we need to do is we need to simplify. See, multiplication or division is first, and then simplify, and then add or subtract. Alright. Now, so then if you have to rewrite number 13, then you can see that 48 is in fact made by 16 times 3. Because we know that 16 is a perfect square. How about the second one? Plus 2 times, that's right, radical 4 times radical 3. Because radical 4 is a perfect square as well. Now, then if I have to simplify one more step, then for the first term, this is what we would have gotten. Second one is this one. So if I have to multiply 2 times 4, we get 8, and then 4 radical 3. When you combine them together, we get 12. Radical 3 becomes our final answer. Alright, so we are continually trying to simplify the radicals. Now notice that if you have perfect squares such as 49, and that's rather easy. But the thing is, did you realize that square root, what it does is that it reduces the exponents by half. That's why square root is a half as an exponent as well. Then the first one becomes square root of 49. See, b squared has a pair. A squared has a pair, which is a times a. In that case, it can come out of the square root, because half of the exponent of 2 becomes 1. So how about b to the 4th power? It becomes b squared. Alright, how about the second term? So we have 16. So as you can see, a squared becomes a, b to the 4th power becomes b squared. Now, how about the last term? Square root of 8 is in fact equal to 4 and 2. And we know that a squared can come out because of the radical, which is square root. But c cannot. So I'm just going to keep c as it is. Now then in this case we get seven ab squared, because square root of 49 is 7. Next one is 4. And then last one is square root of 8 becomes 2 radical 2. 8 times radical c. So when I combine the first two terms, we get 3ab squared. Now the next one is two and a was multiplied together because those are the two factors that are outside of the radical. And on the other hand, 2 and c were multiplied together because those are the two values inside of the radical. Alright. So number 15, how do you simplify a fraction where the denominator is not rationalized? In this case, all we have to do is multiply top and bottom by It's conjugate. That's right. Everything is the same except the sign in the middle, which would have been equal to 6 plus 5 radical 2. Same thing on top as well. Then, what do we end up getting? So I'm just going to leave the numerator as it is. The reason why I'm doing that is because you never know. We might have to cancel things out one more time. Then we will factor anyway. So why do we multiply things out and then factor? And then denominator, when I multiply 6 times 6, we get 36. And then 30 radical 2. And negative 30 radical 2. Okay, the last one is negative 25. Alright, then you will realize that two middle terms cancels out. So I'm rewriting the numerator. How about the denominator? It becomes 36 minus 50 because 25 times square root of 4, which is equal to 2. Then our final answer here becomes 3 times 6 plus 5 radical 3, and then when you distribute, this is what we end up getting. Actually, it should be 2 over here. Notice the negative sign in front of 14. It moves to the front, and hence negative 18 plus 15 radical 2 over 14 would have been our final answer. Alright, let's look at the next question. Number 16. So in order for you to solve this one, we have to add 2 to both sides so that we could have isolate radical by itself. And then to get rid of the square root, we need to square both sides. And we simply get 3x plus 6 is equal to 81. Now, then 3x is equal to 75. Then x seems to be 25. But the thing is, instead of stopping here, why don't you check it just one more time? So then 3 times 25 plus 6 is equal to minus 2 equals 7. Alright, so we get, so that's what we end up getting. 75 plus 6 is equal to 81 minus 2. But that means 9 minus 2, which is equal to 7. So it works. How about number 17? Number 17 is a little bit, seemingly a little bit more complicated. First, we're going to get rid of 8. How are you going to do it? By subtracting 8 from both sides. Then we get negative 4. Then the square root of 2x minus 6 must be equal to negative 2 as well. Why? Because 2 was divided by both sides. Then now when you square both sides here, on the left side we simply get 2x minus 6. On the right side, negative 2 squared becomes 4. So 2x, we know that to be equal to 10. Then x must be equal to 5. So if you have to check 5 to be to see 5 is the answer or not, so I'm plugging 5 into the original equation. Now, then once I do that, I'm going to try to calculate the values inside. And that's basically what we end up getting. Alright, so here our final answer becomes simply 4 plus 8, which is equal to 12. But the thing is this, 12 is not equal to negative 4, that's what we're looking for. And then, since they're not equal to each other, 5, the answer 5, which we thought that we got, wasn't the correct answer. Alright, let's move on to the next question. So since there's no answer, we gotta have empty set or no real solution. Would have been our answer. Alright, let's look at the complex numbers. When you want to simplify square root of negative 45, x to the 4th and y to the 7th, everything is the same except that the negative sign. You see the negative sign will turn the radical into the imaginary numbers. So I can separated a negative sign as just square root of negative 1, which we know that to be I. And then 45 means square root of 9 and square root of 5. And x has been halved in terms of its exponent because we're looking at square root, so we get x squared. How about y? Y to the third, but one of the y still stays in. So then our final answer becomes here. So 3i, those are the only terms that's outside. And then x squared, y to the third, and then 5y, square root of 5y would have been the final answer. How about number 19? So once again, if in order for you to add or subtract, you need to simplify first. So let us try to simplify each one of them. So 5, okay. Square root of negative 18 can be written as just square root of 9 and then square root of 2. Second one, square root of negative 25 and then square root of 2. How about the last one? Alright, so in this case, how can we simplify things further? So the first one, we already had 5, and then square root of negative 9 becomes 3i. So 5 times 3i, square root of 2 here, plus 5i, okay, because square root of negative 25, and then 2, and then the last one is simply 5i, square root of 3. Then we can add up or subtract. So here we get 15, 5. Alright, but in this case, notice that everything has the same value within the radical, except the last one. So when I combine them together, then I can combine the first two parts, and then the last one cannot be added on together because our radicals are not the same. So we couldn't add up the last portion. Alright, so let's look at a couple more questions. Number 20. They want you to graph 4 plus 3i. How do you do that? First, write down the horizontal one. In this case is the real axis, and vertical one is the imaginary axis. So 4 plus 3i simply means in the real part we get 4. So it's almost like having x value of 4. And then 3i simply means 3 units on the I-axis. So that point would have been our point for 4 plus 3i. But if you wanted to draw the vector, sometimes they like to see the visual vector here. You can just start from the 0, 0 origin and to the point 4 plus 3i. Then that's how we can graph it. Alright, how about find the value of I to the 53rd power? How do you get that? So we realize that 52 is multiple of 4. So then we get I to the 53 power is I to the 52 power times I. But what is I to the 52 power? That's simply equal to 1. And then, so our answer is what? Simply I. How about number 22? We just have to multiply those two complex numbers. So all we're going to do is just distribute using the distributive property. So 2 minus 5i times 6 plus 7i. So first, we get 12 by 2 times 6. And then second one is 14i because 2 times 7i. Next one is negative 30i because negative 5i times 6. The last one is negative 35i squared. Alright, so then what do we end up getting? 14i minus 30i becomes negative 16i. And then we get plus 35. Why is that? Because I squared was negative and then it already had a negative sign. Then we can see that our final answer must be 47 minus 16i. Alright, so that was number 22. Alright, let's look at a couple more questions. Number 23. Find the multiplicative inverse. That means we simply are looking for 1 over 7 minus 4i. Now, even though that is an answer, if you wanted to simplify that, meaning rationalizing the denominator, so we're going to multiply top and bottom by its conjugate, which is 7 plus 4i on the numerator as well. Then we get 7 plus 4i, which is rather simple on the numerator. How about the denominator? 49, because 7 times 7. And minus 69 squared. Why? Because the two middle terms has been cancelled out. So then on top we get 7 plus 4i. On the bottom we get 65. Why? Because 49 minus negative 16. So that means when you add them up, we get 65. And then if you wanted to put this one into a plus bi format, then 65 is dividing 7 and 4i as well, both at the same time. So we can say 7 over 65, which means this one, plus 4 over 65i, which is the second one. So that's how we can do it. Now, second portion that they want us to do is find the magnitude. How do you find the magnitude? It's a basically distance formula from the origin. That means absolute value of 7 minus 4i. How do you get that? That's the magnitude. That means square root of first number square, 7 squared, plus, and the second entire number except I, which means negative 4, and that has to be squared. Then we get 49 from the 7 square and 16 from the second square. Then our final answer is square root of 65. That becomes our final answer. Let's look at number 24. In which quadrant would the sum of those two things lie? That means we need to add them up first. So I'm copying down the values, and when I add them up, I realize that my real part is basically negative 2 plus 3, which is positive 1, and the next one is negative I plus 5i becomes plus 4i. Now, imagine, once again, just like the previous question, horizontal axes are the real, and then vertical axes are the complex. Then 1 comma 4, 1 is working as if it's x, and then 4 is as if it's y value, because vertical axes are now the real imaginary axis, vertical one, and the horizontal one is a real axis. Then, since our answer was 1 plus 4i, if you wanted to graph it, then you just have to put the arrow starting at the origin and ends at the point. Alright. And then, when I write this one, the question is which quadrant does the sum lie? Obviously, it's the quadrant number 1. Alright, so now let's talk about some factoring together. How would you factor a when the leading coefficient is not equal to 1? Then what we can do, there are several different ways of doing it. So I'm going to choose this method first. So I'm going to copy the given trinomial and then multiply the first one by last one, which we know that to be equal to negative 6. Then you have to ask yourself, wait a minute. How can two numbers multiply to negative 6 but add up to 5 right over here? That must be equal to 6 and negative 1. That means I can rewrite 5x as 6x minus x. Then 3x squared plus 6x minus x, and then that's basically what we end up getting. From the first two terms, we realize that 3x is common. So then we get x plus 2 is what's left. And then from the last two terms, if you were to factor out negative 1, then we get x plus 2. Alright, then since we realize that x plus 2 is common between both those two, so we can simply factor that out, x plus 2. then we are left with 3x minus 1. That becomes our final answer. How about B? B is a little bit complicated. Let's see if you can handle that one. Here we have, I'm rewriting down the 16x to the 4th power as a difference of two perfect squares. How about that? 16x to the 4th power is in fact square of 4x squared. How about the second one? Y to the 8th power, that means that's a square of y to the 4th power. Alright, then by using the difference of squares, we can rewrite down this one as 4x squared plus y out to the 4th power, and then 4x squared minus y to the 4th power. Alright, now since the first factor we cannot do anything because it's a positive, but the second one, in fact, right over here, I'm hoping that you see the another difference of squares. So we get, I'm going to copy down the first factor here. How about the second one? 2x plus y squared, and then 2x minus y squared. Alright, that's how we can factor those two. Now let's look at a couple more questions. How about C? So did you notice that 2 was common factor in all of them? So when you factor out 2, then we get x squared and minus 5x minus 14. Then when you look at the trinomial, can we factor this one further? Which two number multiply to negative 14 but add up to negative 5? In fact, it was negative 7 and positive 2. And that's basically it for part C. How about part D? When you have 4 terms, then many times you may end up factor things out by grouping. So then we see that x squared is common in the first 2 terms. So here, there we have x plus 3 as the other factor. How about the last 2 terms? Negative 4 was common. Then we are left with x plus 3. Alright, then when you look into these two factored form, x plus 3 is common factor. So when we factor out x plus 3, we get x squared minus 4. But notice that this is a perfect square, a difference of perfect squares. So I'm going to write in the first one as it is. Second one is x plus 2 times x minus 2. Then that becomes our answer. Alrighty, so I'm going to stop here, and I'll see you later. Bye-bye.